a slow dawn before dawn itself, a silence older than sound, a darkness deeper than any night humanity will ever stand beneath. Before galaxies spun, before atoms formed, before light dared to exist, there was only a trembling nothingness, poised at the brink of becoming. Then, in a moment so short it defies language, a fraction of a breath, the universe awoke. Time ignited, space unfolded, a storm of creation erupted from a void so absolute it carried neither memory nor direction. This moment, the first second of existence, is the most distant frontier science has ever attempted to reach. Not with rockets, but with mathematics. Not with footsteps, but with equations and particles that decay before they can be named. To return here is to witness the most violent, sacred birth known to physics. It is to watch the laws of reality write themselves in real time. Gravity emerging from chaos, symmetry shattering like ancient glass, matter winning a silent war against antimatter by the thinnest margin imaginable. This journey does not travel outward, but backward, beyond stars, beyond galaxies, beyond the relic light that whispers across the cosmic microwave background, to the instant where time began, and where perhaps it could one day end. This is not just a story of physics, it is the story of existence itself, a return to the first second, when everything we are and everything we will ever become was born from the quiet thunder of creation. In the quiet dawn of the 20th century, humanity believed the universe was timeless, eternal, unchanging. The stars, thought to be fixed upon an immutable canvas, were ancient guardians over a cosmos that simply was. Without birth, without beginning, without question, the heavens appeared serene, a cathedral suspended in silence, limitless and still, until mathematics began to whisper otherwise. In 1915, Albert Einstein unveiled the general theory of relativity, a new architecture for reality. It described gravity not as a force, but as the bending of space-time. His equations flowed with elegance, yet they carried an unsettling implication. The universe should not be static. The fabric of reality, when solved honestly, wanted to stretch or collapse. It resisted stillness. Something deep within the mathematics strained to move. Troubled by this rebellious flexibility, Einstein inserted a term, the cosmological constant, designed to forcibly hold the universe in balance. Later he would call it his greatest blunder. Yet at the time, it reflected the belief of an era. The cosmos was eternal, and the equations must comply. But somewhere far from the world's great observatories, in the cold clarity of Russian winters, a young mathematician dared to trust the numbers instead of tradition. Alexander Friedmann, studying Einstein's equations, found solutions that refused to remain motionless. They expanded, they grew, they suggested a universe that was not eternal, but evolving. And if it was expanding now, then perhaps, long ago, it had been compressed into something smaller, and before that, smaller still, until all matter, energy, space, and time converged to a singular beginning, a universe that had a birth. Friedmann's work was radical, rejected by many, and received little attention. Yet a seed had been planted, a quiet rebellion against infinite timelessness. Years later, another mind would arrive at a similar frontier. A Belgian priest and physicist, Georges Lemaitre, envisioned the universe not as static, but as a living system, a cosmic story with origin. A universe born from what he called the primeval atom, an ancient, unimaginable state from which everything unfolded. Lemaitre saw creation not as myth, but as physics, not divine miracle alone, but natural event waiting to be understood. He proposed that space was stretching, carrying galaxies apart. It was a suggestion so unusual that many dismissed it. Einstein himself was skeptical. "Your calculations are correct," he reportedly remarked, "but your physics is abominable." Yet even skepticism could not bury truth forever, because while theory fought perception, the universe prepared its first undeniable clue. Across the Earth, at the summit of Mount Wilson in California, Edwin Hubble peered through the Hooker telescope in 1929 and observed a revelation in starlight. Galaxies were not quietly suspended. They were fleeing. Their light stretched into deeper reds, shifted by motion. Not drifting by chance, but rushing outward in every direction. Space was expanding. Reality was not still. It was growing. Hubble did not merely catalogue galaxies. He measured the pulse of the universe's heartbeat. the illusion of eternal stillness shattered. In that moment, the cosmos was no longer a monument. It was a story, and stories must begin. The implications were staggering. If space was expanding today, then in the distant past, it must have been smaller, denser, hotter. The universe pointed toward a primal birth, an ancient eruption of being from unimaginable compression. Not mythic poetry, but scientific inevitability. Still, questions lingered. Evidence was persuasive, but not yet irrefutable. A theory is fragile without fingerprints. A beginning required echoes, relics, fossils of creation. For decades, theorists like George Gamow hunted those relics across equations. Gamow predicted that if the universe began in a fiery origin, it would be filled with the faded afterglow of ancient heat, a whisper of the first light, stretched cold by cosmic expansion. A cosmic background, a residue of the beginning, but proof remained elusive. The echo, if it existed, lay hidden in the sky, faint, chilled, scattered across every direction. A message from the first second, waiting eons to be heard. And then, in 1965, in a small radio antenna in New Jersey, noise interrupted the ordinary. Arno Penzias and Robert Wilson, engineers chasing pigeons and calibrating equipment, stumbled across a mysterious hiss. It did not vanish, no matter how they tuned the instrument, no matter how diligently they removed interference. It came from everywhere, from every horizon, every angle, every quiet patch of sky. Static, ancient, and persistent. A sound older than stars. They did not know at first what they had found, but others did. Physicists had been waiting for this echo, predicting it for years. The hiss was not noise, it was memory, the universe speaking across time. The cosmic microwave background, the cooled remnant of the universe's first light, confirmed a beginning. A fireball faded into faint microwave glow, now stretched across the cosmos, like a soft, eternal ember. The afterimage of creation. A universe with a childhood had just revealed its cradle. With this discovery, doubt faded. Cosmology stepped from philosophy into evidence. The universe was not timeless. It had origin, evolution, history. But to understand birth, observation was not enough. Scientists needed to recreate infancy, to simulate the primal furnace, to compress energy, heat, and matter into the conditions of those first atomic breaths. So humanity built machines, accelerators that hurled particles near the speed of light, smashing them together in flashes of creation's memory. Beneath Europe's soil, the Large Hadron Collider became a modern temple to understanding. In its heart, matter behaved like it did when the universe was less than a millionth of a second old. Quarks danced in freedom before binding into protons. Energy condensed into mass, echoing the earliest alchemy. Each collision was a tiny rewind of time, a microscopic return to conditions long buried, a controlled glimpse of the universe in its infancy. The observations accumulated. Quark-gluon plasma recreated primordial chaos. Higgs boson discovery confirmed a field that gives mass to matter, a key chapter in the universe's early script. Radiation maps from satellites like COBE, WMAP, and Planck traced ancient temperature ripples, frozen imprints of quantum fluctuations magnified into galaxies. The universe was not guessed now, it was measured. And as evidence deepened, the architects of understanding stood in the light of recognition. Lemaitre, once doubted, now revered as father of cosmic origins. Hubble, the observer who witnessed expansion. Gamow, who foresaw the cosmic afterglow. Alan Guth, who proposed inflation, the sudden burst that smoothed the young universe and seeded its structure. They were not explorers of oceans or continents. They navigated equations and radiation. Their compasses pointed backward through time. Their discoveries dug not into Earth, but into reality itself. Through them, humanity learned to treat the universe like an archaeological site. Not one built of fossils and stone, but of photons and particles. Clues carried not in dirt, but in starlight. The cosmos became a record, not a void. A museum of beginnings hidden in microwave whispers and particle collisions. And slowly, a new ambition took form. The goal was not merely to confirm a beginning. It was to touch it, to peel back cosmic expansion layer by layer until the first second could be seen in its raw, unfiltered truth. Scientists sought relics left behind in the fires of creation, radiation fossils, the cosmic microwave background neutrino streams, ghosts from the earliest cosmic instants, still passing through Earth by the trillions primordial hydrogen and helium, elemental signatures forged before stars existed. These were not just observations, they were messages, fragments of a language spoken only once when physics first awakened. Piece by piece, the universe surrendered its history. Space expanded, time marched, radiation cooled, matter formed, galaxies arose. But beneath every transformation lay echoes of that first second, embedded in equations, in particles, in the sky itself. Creation had left fingerprints, in dust, in light, in silence, and the greatest revelation emerged quietly. The universe is not a place, but a story, one that began in fire, spiraled into complexity, and now looks back upon itself through human curiosity. The first second waits not in imagination, but in data, waiting to be traced, understood, returned to. And with each discovery, humanity stepped closer to the beginning, to the moment when time itself learned to move. When existence chose to be, the first clues had been uncovered in cosmic ashes, and the path to the origin had begun. The universe had opened its book and revealed its first page. In the beginning, there should have been nothing, not silence, not darkness, not even emptiness, but true mathematical nothingness, a void without potential, without law, without space to cradle thought or time to feel passage. And yet, against all simplicity, against all probability, a universe exists. This simple truth is the most disquieting revelation in modern science. Not that the cosmos is vast or ancient or expanding into forever. These are wonders, but not impossibilities. The true shock lies deeper. The universe should not have survived its first breath. For in the first second after the Big Bang, nature faced decisions so fragile that a microscopic imbalance, a single altered property, a single different quantum roll of a cosmic die, could have erased everything before it ever began. The universe's earliest moment was not peaceful emergence, but a razor-thin escape from paradox. What came into existence was improbable. And yet here it is, stretching in every direction, ancient light streaming across gulfs of time, galaxies swirling like frozen storms, consciousness rising from stardust to ask how any of this became real. The first shock begins with symmetry, and how the universe broke it. The vanishing mirror of antimatter modern. Physics teaches that matter and antimatter are born together, like twins in perfect opposition. Each particle of matter has a mirror opposite, same mass, opposite charge. And when the two meet, they annihilate in a flash of pure energy. The early universe, blazing and dense, should have forged equal quantities of both. If perfect symmetry had held, matter and antimatter would have erased each other completely. The cosmos would have ended less than a heartbeat after it began, dissolving into a bath of sterile radiation. No stars, no planets, no atoms, not even dust to mark the attempt. But symmetry did not win. For reasons still hidden in the quantum codes of reality, matter emerged with an advantage so small it defies comprehension. For every billion particles of antimatter, there were 1,000,000,001 particles of matter, a 1 in a billion imbalance, but enough to seed everything. This asymmetry is called baryon asymmetry, and it stands as one of the deepest mysteries in physics. Why did nature favor matter? What mechanism tipped the scales? Experiments at CERN and Fermilab search for hints. CP violation in quarks, neutrino oscillations whispering of hidden imbalance. Yet the origin remains uncertain. The universe chose matter over its perfect mirror, and in doing so, chose existence over oblivion. Cosmic coin was tossed, and reality landed improbably on its edge, gravity, and the quantum divide beyond the matter-antimatter. Miracle lies a deeper fracture, a fault line in physics itself. 2. Pillars stand beneath modern science. General relativity, Einstein's smooth geometric description of gravity and space-time. Quantum mechanics, the probabilistic jittering framework of particles and forces. Each works with extraordinary precision, describing worlds immense and worlds infinitesimal. Yet when pushed to the universe's birth, the moment where both scales merge, they clash violently. Equations explode, predictions collapse, space-time shreds into uncertainty. The first second sits, beyond our mathematical reach, a frontier where Physics has not yet learned to speak with one voice. The unification of these theories, quantum, gravity, remains the holy grail of modern physics. Attempts emerge: string theory, loop quantum gravity, holographic models inspired by black hole thermodynamics. None yet proven. Until unity is found, the universe's first instant remains half known, a dream seen through fractured glass. Inflation. Space outrunning light. Then came a discovery more shocking still. A revelation that space itself once raced faster than light. Cosmic inflation, proposed by physicist Alan Guth in 1980, suggests that in a trillionth of a second after the Big Bang, the universe ballooned with impossible speed. Not objects moving through space, but space itself expanding. In ordinary physics, nothing moves faster than light. But inflation was not ordinary physics. It was space-time being created faster than light could traverse it. A moment of surreal acceleration, smoothing chaos, flattening curvature, spreading quantum seeds that would become galaxies. This idea sounded absurd until data aligned behind it. The cosmic microwave background shows uniform temperature with faint quantum ripples, a signature of inflation's smoothing and seeding. The distribution of galaxies across cosmic web filaments matches predictions from early quantum fluctuations stretched vast. The universe's flat geometry echoes inflation's imprint. Inflation rewrote understanding and raised new questions. What force drove it? Why did it stop? Could it happen again? Does it still happen elsewhere? Some theories propose eternal inflation, a multiverse budding endlessly with universes branching like cosmic foam. If true, the observable universe is not the totality of existence, merely one bubble among an infinite sea. In such a vision, our universe is not alone. It is simply one attempt, fine-tuning on a cosmic blade, yet another shock lies in the precision of the universe's early conditions. So precise, it borders on uncanny. If the density of the universe had differed by as little as 1 part in 1060, cosmic growth would have failed. A universe slightly denser would collapse back upon itself in a fiery reverse. Slightly thinner and galaxies would never form, matter dispersing into eternal darkness. The balance was perfect, not approximately, but exquisitely. A cosmic tuning so sharp it challenges randomness. Other fine-tuned conditions emerge. The strength of nuclear forces perfectly binds atoms without crushing them. Gravity is weak enough to allow stars to burn slowly, giving life time to emerge. The cosmological constant, the energy of empty space, is tiny, yet non-zero. If larger, expansion would rip matter apart. Many physicists resist the word fine-tuning, but the numbers speak with quiet force. The universe walks a narrow path between chaos and emptiness, and has done so from its first second, a delicate balance poised between annihilation and possibility. Hawking's quantum seeds into this fragile arithmetic came the voice of Stephen Hawking, who suggested a startling truth. The universe's structure emerged from randomness. During inflation, space was not smooth, it trembled. Quantum fluctuations, tiny, violent jitterings of particles and fields, were stretched across cosmic scale. These quantum wrinkles, magnified to the size of galaxies, became gravitational seeds. Where fluctuations were slightly denser, gravity pulled matter inward. Where thinner cosmic voids formed, the entire cosmic web, stretching hundreds of millions of light years, may be the frozen fingerprint of randomness born in the first instant. From uncertainty came structure, from fluctuation came form, from quantum chaos came cosmic architecture. It is a haunting paradox. The universe is at once wildly random and meticulously balanced. A universe balanced on nothingness. Taken together, these revelations form a strange truth. The universe chose matter over antimatter by a whisper. Gravity and quantum theory remain divided at birth. Inflation outran light to sculpt spacetime. Forces and constants are tuned to impossible precision. Random quantum events wrote cosmic structure. Everything that exists, stars, oceans, thoughts, depends on razor-thin margins, safeguarded by unknown laws emerging from primordial trembling. In this realization, the universe feels less like machinery and more like a miracle. But science allows no claim of purpose, only awe. Physicist Andrei Sakharov once wrote that the laws of physics appear arranged to permit creation. Yet the word arranged remains forbidden without proof. Instead, cosmology holds silence, a silence filled with wonder and discomfort. Why does anything exist? Why did reality not choose symmetry, stillness, void? And if it chose existence, was choice the correct word? Or merely coincidence magnified by time? Modern physics stands humbled before these questions. For every answer revealed, another question deepens. For every certainty achieved, a greater uncertainty rises. The first second of the universe did not merely birth matter, it birthed mystery. Existence in the balance. Even now, the universe remains precarious. Quantum field theory suggests the vacuum may not be truly stable, only metastable, suspended in temporary calm. A deeper energy state may exist, waiting to be triggered. This hypothetical transition, vacuum decay, could rewrite physics instantly, extinguishing stars and dissolving atoms in a wave faster than light. The universe may still be balancing on uncertainty, just as it did at birth. And yet, through this fragile architecture, galaxies form, stars ignite, life awakens, consciousness asks, and curiosity peers back across time. What began as improbable has become aware of its own improbability, all without answer. Scientists do not frame this shock in theology or myth, but in humility. The universe behaves as though finely tuned, yet science cannot assume intention. It emerges from quantum chance, yet speaks in mathematical precision. It avoids annihilation by fragile asymmetry, yet holds structures vast and enduring. Cosmology offers no comfort, only revelation. No triumph, only perspective. The laws existed before minds could recognize them, but now minds recognize their strangeness. The first second suggests not inevitability, but wonder, not certainty, but improbable grace. In that second, everything that would ever unfold, every atom in every star, every ocean, every breath, waited in balance. Existence hung by a thread thinner than calculation, yet strong enough to bear the weight of eternity. And so the greatest shock is simple. The universe exists when non-existence would have been easier. From chaos, form. From randomness, structure. From silence, light. A reality born fragile, yet enduring. A mystery so profound it humbles even the equations that revealed it. And beneath all discovery, one question remains suspended like a star above a dark horizon. Did the universe arise from perfect accident, or from laws deeper than imagination? Science does not answer. It only listens and marvels. The search did not end at the discovery of cosmic echoes. It only deepened, drawing humanity toward a realm where numbers trembled, where theories strained against the edges of understanding, where the universe began to reveal hints of a narrative older than light itself. Once the glow of the cosmic microwave background was detected, a silent cosmic map emerged. Faint ripples in temperature spread across the heavens, painted like delicate scars of creation. These were not imperfections. They were frozen fingerprints of turbulence, ancient whispers of a universe only a fraction of a second old. Within those subtle temperature fluctuations lay an astonishing truth. The universe was not born smooth. It was born wrinkled, uneven, a primordial sea of subtle density waves, destined to become galaxies, stars, and planets. A single ripple, slightly denser than the vacuum around it, would one day collapse into a swirling disk of starlight. Others would drift through time as the quiet void between cosmic islands. These patterns, tiny, fragile, almost featureless, were the seeds of every galaxy humanity would come to know. Physicists traced those ripples back beyond the first light, into a darkness deeper than anything eyes could see. Their origin was inflation, a moment when space itself ballooned faster than light could move, stretching quantum haze into the scaffolding of cosmic architecture. The map of the CMB became a fossil, not of matter, but of space itself, recording how the universe expanded in its earliest, most delicate heartbeat. From this celestial tapestry, science learned to read the universe like archaeologists read soil. Slight warm and cool regions, differing by no more than 1 part in 100,000, carried messages from an epoch before atoms, before forces separated, before time behaved as it does now. It was as though the universe had left behind its birth record, encoded not in words, but in cold radiation drifting endlessly through the void. Yet radiation alone could not tell the full story. There were relics hidden in matter as well, fragments born from the first seconds of cosmic fire. Astronomers measured the universe's lightest elements: helium, deuterium, lithium, remnants forged during the first 3 minutes when the primordial plasma cooled just enough to allow atomic nuclei to form. Their abundance matched the equations of Big Bang nucleosynthesis with remarkable precision. Too much helium, and the universe would seem older than it was. Too little, and the theory would fracture. But the values aligned, as if the universe had followed a script of extreme precision, choreographed by physics, but understood only through reflection. Each observation strengthened the idea that the early universe was not chaos, but structure emerging from unimaginable heat. With every measurement, cosmologists pushed further back, toward the moment no telescope could ever reach, the first second. To approach that threshold, they turned to machines capable of breaking reality apart and watching it rebuild. Beneath the fields of Switzerland and France, the Large Hadron Collider accelerated protons to near-light speed, smashing them together and recreating tiny shards of the universe as it once existed. In those fleeting collisions, temperatures soared to trillions of degrees, echoes of the primordial furnace. Quarks swirled in quark gluon plasma, imitating the universe when it was only a heartbeat old. Sometimes particles flickered into existence only to vanish instantly, revealing how fragile matter truly is when stripped to its foundations. In these collisions, the Higgs boson emerged, the particle that gives mass to others, a cornerstone of reality itself. Its existence confirmed that the fabric of the universe was never empty. Even in the silence between atoms, an invisible field hummed, a cosmic ocean of potential, shaping the very possibility of existence. Its discovery brought humanity closer to that first second, yet also reminded physicists how much still lay hidden. For beyond particles lies a realm even more elusive, the realm of the neutrino. Born in staggering quantities during the first second of time, these ghost-like particles still stream through everything, untouchable, unstoppable, indifferent. Every second, trillions pass through the human body, through oceans, through the planet itself, relics from when the universe was young and violent. They rarely interact, but their existence is proof that the first second did not end. It continues to whisper through reality. Detecting these relic neutrinos remains one of the great quests of modern physics. Instruments buried deep beneath mountains, submerged in Antarctic ice, and shielded from cosmic noise hunt for traces. A flash of light, a faint whisper of energy, a fleeting interaction. Each detection is a glimpse back across nearly 14 billion years, into darkness humanity will never directly see. Yet even with relic particles and ancient radiation, one mystery remained untouched: the spark that ignited inflation. To grasp it, physicists turned to mathematics, bending logic into new shapes, constructing theoretical universes where space is woven from strings vibrating in extra dimensions, where geometry itself becomes granular, where space-time might be a hologram projected from a deeper reality. String theory offered one vision: a cosmos where every particle is a tiny vibrating filament and forces are harmonies in a multidimensional symphony. Loop quantum gravity offered another: space broken into indivisible quantum loops, pixels of existence snapping together to form volume and time. Holographic cosmology whispered a third possibility: that the universe may not be a volume at all, but a projection from information encoded on a distant boundary. Each idea reached for something older than the Big Bang, something hidden beneath light's first breath. Each theory hinted that the beginning may not have been a beginning, but a boundary, a phase transition, like water turning to vapor, like symmetry breaking into form. In these frameworks, time itself might not be fundamental. It could be emergent, a property that arises from deeper order, the way temperature arises from motion, or waves emerge from the sea. Space, too, may not be continuous, but composed of indivisible units. The universe pixelated at unimaginable smallness, like a cosmic screen beneath perception. If so, the universe as known, expanding, cooling, aging, may be only one mode of existence among countless possibilities. The Big Bang could have been a rebirth, not a birth. Inflation might have been the blooming of a universe already written into deeper fabric. The first second, then, would not be the start of history, merely the moment history became visible. These ideas are not proven. They may never be proven, yet they emerge not from myth, but from equations that strain to reconcile gravity and quantum reality, space-time and uncertainty, geometry and probability. Each theory attempts to bridge the canyon between Einstein's smooth space-time and the restless, jittering quantum foam that flickers beneath. And with every new instrument, every calculation, every neutrino captured, the universe seems both closer and further away. Closer because mathematics now touches the edge of creation. Further because each answer reveals new depths beneath the surface of certainty. The deeper the investigation runs, the more the universe resembles a layered manuscript. Pages of physics stacked atop one another, each written in a different dialect of reality. The first light was only the first readable page. Beneath it lie pages written in quantum flame, in symmetry and collapse, in potential and becoming. As the investigation deepens, one truth rises above the rest. The universe is not simply expanding through space, it is expanding through understanding. Humanity stands not at the edge of knowledge, but at the beginning of a journey through unimaginable conceptual terrain. A journey into the microscopic, the foundational, the pre-luminous. With telescopes pointed outward and equations turning inward, the cosmos is not merely observed, it is decoded. From the shadows beneath the cosmic glow to the ghosts drifting through matter, from ancient helium to the quark storms of particle accelerators, every discovery draws the curtain back a little further. Every ripple, every particle, every anomaly is a clue. The first second of time is not an event, it is a frontier, and even now, it continues to retreat, inviting pursuit. For beneath the first light, the universe holds a memory older than stars, older than space, older than time, and science, patient and persistent, continues its descent into that primordial silence, where creation still echoes, waiting to be heard. The deeper the universe is examined, the stranger its birth becomes. What began as a theory of expansion grows into a vision of infinite horizons, each more bewildering than the last. For inflation, once a modest idea describing a fleeting cosmic surge, now implies something far greater and far more unnerving. The universe may not be alone. In the mathematics of eternal inflation, expansion never truly stops. Regions of space cease inflating and cool into universes. But the cosmic field that drives expansion continues elsewhere, endlessly blooming new realms. In this view, the known universe is not the whole, but a single bubble in a vast cosmic foam, one pocket of order floating in a sea of countless others. Each bubble may carry different laws, different physics, different possibilities. A multiverse not born from imagination, but emerging reluctantly from equations too stubborn to ignore. This idea does not offer comfort. It does not grant special place. It suggests that the universe is not singular, that creation was not a solitary event, but a perpetual cosmic breathing. The Big Bang becomes not a beginning, but a boundary between what can be seen and a deeper realm that cannot. Origins dissolve into landscape, and existence becomes one petal on an infinite cosmic bloom. Yet inflation brings another revelation, one not of endless birth, but fragile survival. Quantum field theory proposes that the vacuum of space is not empty, but full of restless potential. Fields hum beneath matter, poised between stability and collapse. If the universe rests in a metastable state, not the lowest possible energy, but a temporary calm, then reality itself may be living on borrowed time. One quantum fluctuation, one cosmic trigger, could send the vacuum cascading into a lower energy phase, erasing atoms, light, space-time, all in an instant. A cosmic reset beyond warning, beyond resistance, beyond comprehension. This possibility is not a prediction. It is a reminder. The universe may be far less permanent than it appears. To understand such fragility, physicists turn to the earliest imaginable moment, the Planck epoch, a time so brief that language strains to describe it. 10 trillion trillionths of a second after the beginning, 1043 seconds. Before that instant, equations break. Gravity refuses to merge with quantum behavior. Time, as normally understood, loses meaning. Space itself cannot be defined. The Planck epoch marks not a moment in time, but the edge of understanding, a wall beyond which no telescope, no collider, no theory has fully passed. At that boundary, the universe was small enough to be ruled by quantum chaos, yet dense enough to curve into itself. Space may have foamed with microscopic black holes, flickering and evaporating in bursts of Hawking radiation. Geometry may have vibrated, warped, torn, rejoined. The familiar laws of nature slept, yet to awaken when the universe expanded and cooled. Physicists seek unification, a single framework binding quantum mechanics to gravity, but each attempt reveals complexity beyond imagination. The Planck epoch stands like a locked chamber, its door sealed not by mystery, but by mathematics, and yet clues emerge, subtle, elegant, unsettling. Black hole thermodynamics reveals that gravity behaves as though space holds information, not merely matter. Horizons possess temperature and entropy. Evaporation follows thermodynamic law. In these insights, the boundary of a black hole begins to resemble the boundary of the universe itself. Some models propose that the cosmos may be a kind of horizon, a holographic projection of deeper information, spread across a surface that cannot be touched or seen. In such visions, the Big Bang is not a point of infinite density, but a phase transition on a cosmic screen. The singularity becomes a mirage, not a location, but a breakdown of description. Space, time, energy, existence, all emerge from information woven into the geometry of reality. This symmetry becomes haunting. The universe's beginning and its potential ending share the same mathematical scars. Singularities at both birth and death, in black holes and in cosmic origins, hint at a deeper unity. Where time begins, it also threatens to collapse. Where structure forms, it also dissolves. The forces that forged galaxies also feed the darkness that may eventually consume them. Yet the universe does not simply move toward darkness. It accelerates outward, spreading faster with time, as if driven by something unseen. What was once expected to slow, the expansion of space, now speeds up. Galaxies drift beyond the cosmic horizon, vanishing not into shadow, but into unattainable distance. Dark energy, the silent force behind this acceleration, fills the cosmos like a gentle tide, slow yet relentless. Einstein once added a term to his equations to keep the universe static, a cosmological constant, later abandoned when expansion was discovered. Now it returns as the engine of acceleration, the quiet breath inside empty space. But its nature remains unknown. A constant, a field evolving through time, something else entirely, woven into the universe's deepest structure. As expansion accelerates, the symmetry sharpens. A universe born in rapid inflation begins to end in slow inflation. The beginning and the far future mirror one another, like bookends to cosmic narrative. The first second and the final trillion share a common thread. The stretching of space, the isolation of matter, the slow dimming of light. Yet while theory reaches towards symmetry, observation reveals discord. Two measurements of the universe's expansion refuse to agree. Nearby cosmic objects, stars, galaxies, supernovae, tell one story. The early universe, read through the cosmic microwave background, tells another. The Hubble constant, once a symbol of certainty, fractures into two values, separated by stubborn disagreement. Precision grows, yet the gap remains. This is not noise, it may be warning. The universe may be hinting at cracks beneath its surface, or at layers not yet understood. Dark energy might evolve through time, shifting its influence like a tide. Early inflation might have left scars not yet resolved. Primordial anomalies, unexplained temperature alignments, unexpected fluctuations, linger in the cosmic map like fingerprints of unknown processes. They are faint, elusive, easy to ignore, yet persistent, like whispers from a past that refuses to stay quiet. Some scientists suspect hidden particles. Others propose new interactions, or symmetry breaking beyond the standard model. Some suggest that the universe may not be isotropic, that subtle directionality may exist. And a few wonder whether the universe's earliest moments were governed by physics more complex than any current equation. In each anomaly lies escalation, not of danger, but of wonder, not of fear, but of humility. Every discovery deepens the paradox. The closer the universe is approached, the more it recedes. The more equations explain, the more questions emerge. The origin refuses simplicity. It defies neat closure. It stretches imagination, bends theory, demands courage to confront a cosmos where certainty may never fully arrive. In this unfolding, humanity becomes not conqueror of knowledge, but apprentice to a universe far larger than mind can encompass. Instruments probe deeper. Equations stretch further. Yet the beginning remains shrouded, protected not by secrecy, but by scale, by energies beyond reach, by realms beyond light, by logic not yet born. To explore origins is to walk between awe and impossibility, to accept that nature may reveal truth slowly and sometimes not fully. Yet the pursuit continues, driven not by answers, but by the need to ask. For in the face of a universe that should not exist, curiosity becomes defiance, and understanding becomes not a destination, but a horizon, eternally approached, never reached, yet always illuminating the path ahead. Before the first second, before light ignited and matter learned to exist, lies a horizon that language cannot quite cross. It is not darkness, for darkness itself is a property of time. It is not silence, for silence implies the presence of sound. It is not emptiness, for emptiness assumes a stage on which things could be absent. It is something older than beginning, and perhaps something that does not belong to time at all. In the pursuit of cosmic origin, science reaches an edge. Equations stretch, but they strain. Logic pursues, but it stumbles. And yet the human mind refuses to stop. Where observation ends, theory begins. Not fantasy, but disciplined imagination guided by mathematics and evidence's faint fingerprints. Across decades, physicists have constructed models not to declare truth, but to glimpse possibility. Each asks the same question in a different way. If time began, what lies beyond its frontier? Or more provocatively, if time is not fundamental, what breathes reality into existence? The universe. Without a beginning in the 1980s, Stephen Hawking proposed a bold possibility. Perhaps the universe has no edge in time. His no-boundary proposal, developed with James Hartley, imagined time not as a line, but as a curve. A sphere has no first point, it simply is. The universe, in this picture, emerges smoothly, without a singularity, without a sharp beginning, without a moment of creation carved from nothingness. Here, time behaves like space at the earliest era. The Big Bang is not a flash of origin, but a transition. The moment time becomes distinguishable, the moment temporal direction crystallizes like ice forming on water. This does not erase mystery, it deepens it. A universe without a boundary is not a universe without wonder. It is one where the past fades not into chaos, but into geometry, a realm where time dissolves into structure, where creation becomes a gentle unfolding rather than an explosion. The universe. That breathes other visions, picture a universe that contracts before it expands. A cosmic breath across eternity. Bounce cosmologies propose that the Big Bang may not be the first, that it may instead be the latest in a chain of cycles. A universe expands, cools, thins, and eventually collapses under its own weight, born again in a burst of heat and density. The Big Bang becomes not an origin, but a heartbeat. In such models, the arrow of time may flip during collapse. Entropy's direction may reverse or reset. Everything old is crushed into potential, and potential becomes reality once more. Stars may rise again from the ashes of ancient stars, galaxies from ancient galaxies, physics from ancient physics. The cosmos becomes not a single act of creation, but an eternal rhythm, contraction, explosion, renewal. No memory bridges cycles, no relic crosses the boundary, but mathematics allows the whisper. This is not the first universe. It may not be the last. The infinite garden of universes inflation, the rapid expansion that sculpted the early universe, carries another implication, one as vast as it is unsettling. Eternal inflation posits that the field-driving expansion does not end everywhere at once. It ends only locally, patch by patch, birthing universes like seeds scattered across an infinite field. The rest continues inflating, pushing these pocket universes apart forever. In this vast cosmic garden, each universe grows alone. Some may be rich with matter, others, silent and still, barren of structure. Some may have physics so alien that atoms never form, or time never flows as understood. This is not a story of alternatives for drama's sake. It is the natural extension of inflation mathematics, a framework many cosmologists treat not as imagination, but as consequence. If so, existence is not solitary. The cosmos is not a universe, but a multiverse blooming beyond comprehension. Humanity lives not in the only reality, but in one reality among countless. Strings and landscapes. In string theory, the building blocks of matter are not particles, but vibrating strings. Their patterns of vibration determine mass, charge, and force. But these strings do not float in ordinary space. They require additional dimensions, curled into microscopic shapes beyond perception. Within this framework lies an astonishing implication. There may exist a landscape of possible universes, perhaps 10,300 of them, each corresponding to a different configuration of extra dimensions. Most would be lifeless, some would collapse instantly. A rare few, perhaps like ours, would hold the delicate balance that permits matter, chemistry, stars, structure, and life. This is not design. It is selection from immensity, not purpose, but possibility spread across unimaginable scale. Time without beginning, time without end, Sir Roger Penrose offers a different cosmic eternity, conformal cyclic cosmology. In his model, the distant future of one universe becomes the beginning of another, not through collapse, but through dilution. As the universe expands forever, matter decays, black holes evaporate, particles lose mass, and the cosmos becomes pure radiation. Without scale, without clocks, without mass to anchor time, the far future stretches into something indistinguishable from a pre-Big Bang state. The death of one universe becomes the birth of the next. Cosmic epochs link like pearls in an infinite chain, each universe leaving faint imprints on the next. Penrose argues such signatures may hide in the cosmic microwave background, concentric circles, faint scars from supermassive black holes in a previous aeon. Whether confirmed or not, the idea carves a space in thought. Time may not reign eternal forward. It may recycle itself, reshaping reality into new form again and again, an endless wheel of cosmic rebirth, a universe awaiting collapse. Not all visions are gentle. Quantum field theory allows another fate. Reality may sit in a metastable state, a false vacuum perched above a deeper energy level. One quantum fluctuation, one cosmic event, could trigger a transition to the true vacuum. The bubble would expand at the speed of light, rewriting physics in its wake. Atoms would dissolve, space would transform, time would fracture. There would be no warning, no sign, no sensation, only instant dissolution. The universe would not end so much as change into something that cannot host what once existed. This idea does not predict doom. It merely reminds that stability is a gift, not a guarantee. Existence may be perched delicately atop cosmic possibility. When time emerges as theories stretch toward origin, a radical idea takes shape. Perhaps time is not fundamental at all. In holographic cosmology, space and time arise from deeper informational structure. Quantum bits woven across surfaces. Reality becomes emergent, not fundamental. Time flows because information changes, exists because structure grows. The arrow of time may be born from entanglement, not built into the universe from the start. If time emerged, then asking, what came before, becomes like asking, what is north of the North Pole? Before time is not a moment. It is a realm without chronology, a domain where causation waits to be born. The edge of understanding. Each theory stretches imagination, yet remains tethered to mathematics. None claim final truth. Each is a lens through which the earliest universe is glimpsed, faintly, imperfectly, but with growing clarity. Across them runs a shared whisper. Creation may not be a point. It may be a process, a cycle, a transition, an emergent phenomenon. The first second of time may not be the dawn of everything, only the dawn of this form of existence. And so the mystery deepens. In the absence of certainty, reverence grows. Not awe born from ignorance, but awe born from knowledge pressed against its boundaries. For to ask what happened before time is to confront the greatest humility. The universe may be larger than comprehension, older than beginnings, stranger than imagination. Time may be a shadow cast by deeper reality. Creation may be perpetual, eternal, cyclical, emergent, or something beyond all human language. What came before the first second? Perhaps another universe, perhaps none. Perhaps a realm where before has no meaning. Perhaps the universe simply is, unbound, unoriginated, unfolding like a thought from laws beyond time. In this pursuit, science does not seek finality. It seeks understanding and finds wonder. It explores not to end mystery, but to illuminate it. And somewhere between equations and stars, between quantum fields and cosmic horizons, the question remains suspended in silence. What lies beyond beginning? Where does time come from? And is creation a moment or a truth without end? In an era when the universe has aged nearly 14 billion years, a quiet revolution unfolds. Not in the roar of rockets, nor in the cries of discovery shouted to crowds, but in hushed laboratories, mountaintop domes, and silent machines staring into the void. There, humanity attempts something once reserved for myth: to chase the first second, to peel back the sky until only creation itself remains. The universe, ancient and vast, keeps its secrets close, yet modern instruments press against that cosmic silence, whispering questions to the darkness. Questions as old as wonder and as daring as imagination. They do not seek stars or planets. They seek the moment before such things were possible. They seek the spark when everything, all mass, all energy, all future histories, was compressed into a fire more fierce than any star. The quest is not merely to see deeper into space. It is to see earlier in time, to approach, step by delicate step, the frontier where physics trembles, and creation hesitates between being and nothingness. In the cold vacuum beyond Earth's atmosphere, a new eye opened to the ancient night. The James Webb Space Telescope, born of decades of engineering and fragile ambition, unfolded like a cosmic flower. Its mirrors, golden and delicate, gathered the oldest light ever touched by human hands. Infrared whispers stretched thin by time itself. And that light carried a surprise. Galaxies, massive, complex, already burning with stars, appeared at ages where theory insisted only chaos and youth should reign. Cosmic infants should not have grown so quickly, yet there they stood in Webb's vision. Ancient giants inhabiting a universe scarcely begun. Some sat within the first few 100 million years after the Big Bang, a blink in cosmic history. Too mature, too luminous, too formed. Models groaned, timelines flexed, equations whispered of something missing, a universe perhaps more efficient than expected, or a past more turbulent than textbooks had assumed. These galaxies are not just distant, they are clues, breadcrumbs left at the dawn of time. Each new object Webb reveals sharpens the riddle. How did structure rise from the primordial haze so fast? Did gravity grow stronger upon birth? Did dark matter shape the early cosmos more fiercely than thought? Or do human equations simply falter when pressed against the first breaths of existence? No answer yet, only wonder. And the quiet tension of discovery coiled on the edge of revelation. Beyond Webb, Earth prepares more eyes to watch the heavens awaken. Euclid, launched by Europe, sweeps the sky in wide strokes, mapping billions of galaxies, tracing how cosmic structure stretched across expanding space. It hunts for the fingerprints of dark energy, the mysterious force pushing the universe apart faster and faster. And soon, the Nancy Grace Roman Space Telescope will join, an observatory designed like a wide-angle web, a sentinel poised to reveal the scaffolding of the cosmos in unprecedented detail. Together, they do not merely look outward. They measure the universe's shape, its growth, its breadth. They reach for the signature left by whatever ignited cosmic inflation. That sudden flowering of space so violent it outran even light. If inflation sculpted reality, these instruments will read its chisel marks in the way galaxies cluster, in the subtle stretching of space between them, in the shadows that dark energy casts across eternity. To map the universe is to interrogate its origin. Every filament of galaxies, every void between them, is a fossil of the universe becoming itself. But light is not the only messenger from the first moments. In deep caverns, beneath mountains and ice, machines wait with patient silence. They listen not with lenses, but with stillness, for particles that rarely speak, yet never stop traveling since the universe was born. Neutrinos, ghostly travelers, born in nuclear furnaces and cosmic fire, flow through Earth by the trillions each second. Most pass without touch, without trace, ghosts gliding through steel, stone, flesh as though reality is vapor. But IceCube, buried beneath Antarctic ice, a lattice of sensors frozen in the purest water on Earth, can sometimes hear their faint murmurs. A flash of light beneath the polar surface, a whisper of energy from a particle older than planets. The cosmos has spoken. One relic captured from the dawn. Physicists dream of detecting not just neutrinos from stars, but those from the first second, a primordial neutrino background, born when the universe was a furnace of quarks and light, a whisper far more ancient than the cosmic microwave background itself. To catch even one such relic would be to hold the first heartbeats of reality in a single number, a measurement, carved from the silence before atoms existed. Elsewhere, detectors tuned to the fabric of space-time itself listen for deeper tremors. LIGO, Virgo, Cagra, instruments so sensitive they can feel space-time shiver from black holes colliding billions of years away. Each chirp is a cosmic obituary, stars collapsing, universes in miniature ending in graceful spirals. Yet scientists hope for a rarer sound. Primordial gravitational waves, echoes of the instant inflation began, not produced by stars, but by space tearing into existence. The universe ringing as it ignited. Future observatories dream to hear this overture. CMB-S4, a network of telescopes, will stare at ancient microwave light searching for a faint swirl. A polarization pattern curling across the sky, sign of gravitational waves from the beginning. Should such patterns be found, they would reveal the universe not simply glowing from birth, but trembling from creation. They would confirm inflation not as speculation, but as the very first motion the cosmos ever made. While telescopes peer outward and detectors listen inward, another frontier rises in the realm of matter itself. In vast rings beneath countryside and cities, atoms are hurled until they near the speed of light. At the Large Hadron Collider and future-planned colliders, protons collide with energies that mimic the universe when it was less than a trillionth of a second old. Out of the wreckage, particles bloom, some fleeting, some foundational, echoes of the primordial soup. These collisions confirm the Higgs boson, proof that particles gain mass through interaction with a cosmic field. A hint that even emptiness is structured, alive with invisible forces shaping existence. Yet the Higgs holds another question. Is our universe stable, or is the vacuum itself temporary? A delicate balance that might someday collapse into a lower state. If instability lurks, a quantum tremor could rewrite physics in an instant, spreading at the speed of light, unnoticed until arrival. Cosmic vulnerability hidden beneath familiar skies, such is not fear, but perspective. To study the Higgs is to study whether existence is secure or suspended by probability, and future colliders promise deeper revelation. Searches for dark matter particles, for symmetries broken at birth, for forces that shape the universe in silence. For in the heart of matter lie echoes of the first second. To smash particles is to strike the universe like a gong and listen to how it once sang. Beyond accelerators and telescopes, another tool awakens, not built from steel or glass, but from logic and electricity. Supercomputers, with circuits humming like a distant hive, simulate universes grain by grain. They model quarks swirling in primordial plasma, dark matter collapsing into cosmic web, galaxies rising, stars forming, planets spinning from dust. Some attempt a grander feat, to simulate the instant time ignited, to fracture the first second into equations and code. And emerging at their side, artificial intelligence learns to recognize patterns the human mind cannot hold at once. It studies cosmic maps, gravitational waves, particle collisions, searching for anomalies, for threads that theory has missed, not replacing curiosity, but amplifying it. A new partner in humanity's oldest question. Soon, AI may guide telescopes where to point. It may sift through cosmic noise for relic signals older than galaxies. It may expose subtle cracks in our understanding where deeper truths lie waiting. And if the universe hides its birth behind complexity, then intelligence, biological or synthetic, may be the tool evolution grants to pierce the veil. Through all this effort, through crystals buried under mountains, through mirrors floating in space, through machines that bend matter to its limits, a singular goal endures: to approach the moment before order, to watch the first second unfold, to answer a question older than language: how does nothing become something? Each experiment, each instrument, is a lantern held to the darkness. Some reveal stars, some reveal laws, some reveal ignorance so vast it humbles ambition. Yet all move forward, driven not by certainty, but by wonder. The first second remains hidden, like a memory the universe refuses to share. Not by malice, but by nature. Creation was not gentle, it was not quiet. Energy roared, forces collided, space inflated faster than light could chase it. Particles flickered into being, colliding, annihilating, reappearing, until from fire, structure emerged. To understand that moment is to understand why stars shine, why atoms endure, why time flows. To glimpse it may one day reveal why anything exists at all. And so, observatories rise, detectors wait, particles collide, algorithms learn. Humanity stands on the shore of the greatest mystery it has ever faced, not to conquer, but to understand. For to chase the first second is not merely to look backward, it is to look inward, toward the laws that raised matter from void, mind from matter, and curiosity from mind. The cosmos, vast and ancient, invites no easy revelation, but each tool, each insight, brings the horizon closer. Creation lies not in the past, but in discovery, in the slow, patient illumination of secrets that have waited since time itself began. And somewhere in that pursuit, within data streams and starlight, a truth approaches, quiet as dawn, profound as existence, inevitable as time. Soon, perhaps, humanity will stand at the threshold of the first second and see, not chaos, but the architecture of becoming. Not an explosion, but an awakening, not randomness, but laws unfolding. And in that revelation, the universe may speak its oldest word, not in language, but in understanding, an origin, not of matter alone, but of meaning. Before stars learned to burn, before atoms learned to bind, before space learned to stretch and time learned to flow, there was only a silent potential, a seed of everything suspended in darkness without meaning, without memory, without witness. For billions of years afterward, the universe expanded in solitude. Galaxies spun in elegant spirals, nebulae blossomed like cosmic gardens, but no voice rose to ask why. Reality existed without reflection, a grand cathedral unobserved, a story without a reader. And then, much later, in a quiet corner of an ordinary galaxy, a star lit the skies of a small blue world. Around it, matter assembled with slow devotion. From dust, oceans. From oceans, chemistry. From chemistry, curiosity, life stirred. Senses opened, minds awakened. And somewhere in the long unfolding, starlight learned to think. Carbon forged in dying suns organized itself into creatures who questioned the night. Calcium from ancient stars shaped bones strong enough to stand upright and look toward the heavens that birthed them. Iron atoms, once flung from supernovae, pulsed in hearts, learning to feel wonder. Across millennia, thoughts deepened until one species learned to measure starlight, to rebuild the history of galaxies, to calculate the birth of time itself. At last, the universe, through fragile minds, began to know it exists. Not through instinct or reaction or raw survival, but through reflection, curiosity, and awe. Consciousness did not merely arise in the universe. It arose as the universe, a piece of the cosmos gaining the ability to look back at itself. This is not metaphor. It is chemistry raised to vision. It is physics learning to feel questions. It is quantum dust studying the moment dust first learned to be. Stars did not choose to shine, but consciousness chooses to wonder. The paradox of origins remains sharp as ever. Why does existence exist? Why does emptiness not reign instead? Why are there laws, mathematical, precise, delicate, instead of nothingness without structure or possibility? Physics describes how the universe evolves. It does not yet explain why it is allowed to be. Some theories whisper inevitability. Given quantum fields, emergence is unavoidable. Others suggest ephemerality, a fluctuation destined to fade, a temporary island of order in an endless sea of potential. Perhaps existence is one roll of the cosmic dice, one universe among countless siblings beyond perception. Or perhaps it is a singular miracle in which the improbable triumphed not through chance, but through laws deeper than human mathematics can yet hold. Time itself is suspect, a dimension perhaps emergent, a river not always present but born in the first instant, flowing only in one direction, carrying galaxies toward cooling, stars toward silence, minds toward memory. A universe that once knew no meaning now contemplates its own fate. It sees heat death on the horizon, a slow dimming where stars exhaust their fuel and motion dwindles into stillness. For now, energy flows, complexity rises, life wonders. But in distant epochs, entropy calls, and so existence becomes a fleeting spark, a temporary flare against infinite dark. If the cosmos ends in silence, what then of the journey that led to awareness? What of questions asked while stars still burned? Some suggest cycles, a universe reborn again and again, eternity not as endless duration, but as endless becoming. Others imagine expansion without return, a one-way flowering that ultimately fades. And still others whisper that meaning is not constrained by physics. For meaning arises in minds, and minds arise in matter, and matter arises from the laws of nature that allow being in the first place. Meaning, then, is not imposed upon the universe. Meaning is the universe, seen through the only instruments capable of perceiving it, conscious observers. To return to the first second is not only scientific, it is existential. It asks a softer and deeper question. What is humanity that it seeks the birth of time? Not predators, not machines, not mere branches of biological necessity, but witnesses, narrators, bearers of curiosity in a cosmos otherwise mute. From the first spark of fire on ancient Earth to the first image captured by telescopes peering across billions of light years, humanity has been chasing its reflection, not in mirrors, but in stars. Every equation written, every observatory launched, every simulation run is a gesture of remembrance, a recognition that existence is not simply to be lived, but to be understood. To study origins is to rediscover childhood, the cosmic infancy where forces danced and structure took form, and every discovery draws consciousness closer to the cradle it never saw but always sensed. This pursuit carries humility, for every answer offers only deeper corridors of mystery. The more the cosmos reveals, the more it conceals. There is no arrogance in looking backward. There is reverence, a quiet knowledge that to know where one comes from is to honor the chance to exist at all. The atoms in human bodies are ancient, the calcium older than Earth, the hydrogen older than stars, the iron forged in stellar death. Yet the awareness housed in those atoms is new, a whisper on cosmic scales, a momentary spark that illuminates existence then fades back into the night. And in that fragile span, it feels wonder, it feels curiosity, awe, longing to understand. Not as conquest, but as tribute. If the universe is fleeting, consciousness makes its brief light sacred, for a cosmos without observers is a poem unread, a symphony unheard, a dream without memory. But with awareness, with thought, reflection, understanding, the universe becomes a story. Physics gives structure, consciousness gives meaning. One without the other is incomplete. Together, they form the totality of being, existence and recognition interwoven. A star may burn brighter than consciousness, but a mind can imagine entire galaxies. It can ask where they came from and where they will go, and why there is anything to ask about at all. Through awareness, the universe finds its witness. Through science, it finds its narration. Through wonder, it finds its soul. Perhaps one day, future species, born of Earth or stars, will look back upon this age not as infancy, but as awakening, the moment when minds first reached beyond survival and stretched toward origin, when curiosity transcended necessity, when knowledge became more than tool, it became identity. In that sense, humanity is not separate from the cosmos. Humanity is the cosmos, learning to know itself, a universe awakening to itself through fragile, luminous minds that burn for only a brief time, yet reach for eternity. And so the story bends inward, returning not to equations or telescopes, but to meaning. For in the end, origin is not only about the beginning of matter, it is about the beginning of significance. A universe without awareness merely is. A universe with awareness remembers. It recalls itself through the eyes of those who study it, through the hearts that feel wonder at starlight, through the minds that chase the first second not to control it, but to understand their inheritance. And in that pursuit, the cosmos speaks through them, not in words, not in sound, but in the quiet revelation that existence is more than physical. It is meaningful simply because it can be known. In the vast dark between galaxies, silence reigns. But here, on this small world, a flicker of thought persists, temporary, vulnerable, precious. And until the final star fades, it will wonder, because that is what the universe does now. It wanders through us. We are the memory of the universe, looking back across eternity to where it first became possible to remember. We are its story, brief but luminous, a single breath in cosmic time, filled with questions, lit by curiosity, held in awe. And as the last light of this reflection softens, a truth settles like dust across still air. The universe once did not know it existed. Now it does, because part of it learned to ask why. Outro, whispered, fading like starlight. Somewhere, across immeasurable space, stars continue to rise and fall, time continues to unfurl, and awareness continues its fragile bloom. The universe awakens, one question at a time.